in class. So, सबसे पहले, first of all, you need to tell that what is area. How do we define area? Anyone? Nakshatra, you tell me what is area? बोलो. Anyone? अंकित, तुम बताओ एरिया क्या होता है? Hmm?
So area is a measurement of the size of a two-dimensional figure.
Hmm. So area basically it's not just measurement. Measurement of area is something different. Area is any covered space on a two-dimensional space is called area. Okay. So it measurements actually says about the size of area. Okay. So whenever any particular area is there, when we say area, it also suggests the measurement of that particular area also. So of course, to know that whether particular area is big or small, or how big or how small, or any comparison between two areas, like which one is bigger or which one is a smaller, you need to have a measurement scale also. So what measurement scale do we use to measure area? So that is, you will say that it will be square unit. What is in square unit? So let's take an example of rectangle. So this is in a rectangle whose length is 5 unit and width is 3 unit. And matlab like in regular practice, this particular side is called length, because we anything vertical we call it length, but basically the normal standard definition of length says ki whichever is bigger is called length. So will be whatever the definition you follow. Let's say that one of the side is having 5 unit of length, and second side has 3 unit of length. So what we try to see that how many squares of 1 unit by 1 unit is there. 1 unit by 1 unit is there, and this particular square will be called 1 square unit. Okay, so it can be meter, it can be centimeter, it can be feet, it can be anything. So when we to measure it, when we'll go for to count it, that how many of these squares are there in this particular figure, let me draw 3 lines of 1 unit each, and then the distance of 1 unit each. And let me also draw 5 lines of 1 unit uh, in a distance of 1 unit each. So now you can count that there are total 15 boxes in this figure. So rather than counting it, we could have calculated or counted it in a multiplication format, and we could have called it 5 into 3 boxes are there. So this is how we define area, and this is how we calculate the area of a rectangle by multiplying length into breadth. So L into B is our area, and it in this case it is 15 square unit. So why I am using this U every time? Because it can be anything. It can be centimeter or meter or feet or kilometer. Any you can use any uh, measure of length. So this is how we we found the formula of area for an rectangle. So if we now with this formula, we will derive the other formulas for area. So let's say if I have a square, and square has 4 unit length and 4 unit of width. So again, from the same formula, it will be 4 into 4 boxes, and if the length of an side for a square is A, then the area of square will be A into A, which is A square unit. Now let's take an right angle triangle. So if we have a right angle triangle whose perpendicular sides are given, like if it is B and if it is H, or let's say uh, P, B and P. So how do we calculate the area of this triangle? So before calculating it, let's complete the rectangle, which can be made by uh, drawing a parallel lines to the base and the perpendicular, two parallel lines to the base and perpendicular, and then we'll get a rectangle here, which is divided into two parts with this hypotenuse, and area of this triangle will be equal to area of this triangle. So area of the triangle will be half of area of rectangle, which is nothing but P into B. So for right angle triangle, where we are representing the right angle sides, which are making right angles as perpendicular and base, we'll write it like this. But if we'll call it base and height, so the area of this triangle will be half into B into H. So now what will be the area of a triangle which is not right angle, like area of a triangle. So this particular symbols represent any triangle. So let's say we have a triangle which is drawn like this. So from the definition of triangle, we know there are three sides. So all the three sides will have a corresponding height. So let me draw heights for all the three sides here. So if this is a triangle, and if this side will be called base 1, if this is called base 2, and this is called base 3. So a, a height which is drawn from point A to this base 1 will be called h1, height 1. So every triangle will have three sides, which can be considered as three bases of triangle, and every triangle will have then three heights also, corresponding heights. So h1 will be height for base 1 only. Similarly, h2 will be height for base 2 only, and h3 will be height for base 3 only. So before uh, going ahead, I'll just warn you that this is only true if we are taking height of the same base. So if there is a random triangle and you have been given the base as well as height of the triangle, height, I mean corresponding height of the triangle. So how will you calculate the area of this triangle? So we will again make a rectangle by completing the figure like this. And what do we see here is this triangle is equal to this and this triangle is equal to this. So in this rectangle, uh, in complete rectangle, which I have completed with a dotted line, in this rectangle, there are two parts, one which lies inside the triangle, one which lies outside the triangle. And area of both will be same. And the area of triangle rectangle is B into H, because this H is the height of width also. So the area of triangle will be half into base into height. So this is your formula for area of triangle. So now once you've got the area of triangle here, uh, with an warning or precaution that these should these two base and height should be corresponding, matlab corresponding to each other, to each other. So if there is a triangle like this drawn, and this is base and this is a height, and someone gives you that this figure is 8, matlab this line is of length of 8 and this is of 3, and ABC is the name of the vertical. Now, if I'll ask you, what will be the area of triangle ABC? What will you say? Just tell me. What will be the area of triangle ABC? Anyone? Sanju, Salu, Yasmita, anyone tell? What will be the area of this triangle? If these two figures are given only, the base and the height, but they are not corresponding to each other. So in this case, you cannot calculate the area from the formula which was given. We have to find the corresponding base and height, then only we can find the area. Of course, Alu, but the point is you cannot find the area, or neither anyone can find the area. Let me tell you the difference between these two statements. With these two figures, the triangle cannot be fixed. So if the triangle is not fixed, it is a case of data insufficient. Okay, data insufficient because uh, we don't have complete data to fix the triangle. So in this case, the why we are calling it data insufficient, because with the same figures 8 and height of 3 we can have multiple triangles. So we could have a triangle like A dash BC, uh, A double dash BC. So all these triangles have the same measures which are given for the first triangle, which is 8 as in base and 3 as in height. So that's why even matlab, not only we can uh, not only we are unable to find the area, but it cannot be found also. But and why I'm telling you this, because many of the time you'll find a situation that any DS question, any data sufficiency question, you will find that there is a situation where triangle is fixed. Like triangle is somehow fixed. Uh, Let me give an example. Um let's say these two sides, and this angle is given. Let's say 70 degrees given. So the question will be, can we find the area? Can we find the area of triangle ABC? Triangle area of triangle ABC. So what we can see here that till now we have not studied any formula which has these measures to find the area of the triangle. Because what till now what we know that we need to have a base, we need to have a height, corresponding height only. But here the answer would be yes. We might not calculate the area by ourselves, but the triangle is fixed, because with the same figures, with this 70-degree angle between these two sides and 5 and 8 the measure, the triangle is fixed. There is no other way to create the triangle. So the area of the triangle can be found, but we might not able to find it, but somebody might. So in DS question, you are concerned with only the fact whether it can be found or not. So in geometry, one of the matlab, these type of questions is very favorite, where they will give you a certain condition and they will ask you whether you can find the area or not. So you need what you need to get confirmed that whether the structure is fixed or not. So here the structure is fixed with these three data. So we can actually find the area if not with the formula, by some other way. So but again, in the case of triangle, many of the time we might not need to fix. We might, na, I'll talk about the such situation also. We might not need to fix the shape also in some cases. Like one of the case is, let's say there is a parallel line. Not there is a parallel line. There are two parallel lines. Just a second. So these two parallel lines are there, and there is a fixed base. This is the base, and let's call it BC. And a triangle is being drawn between these two parallel lines, where one parallel line will have vertex, and the other parallel line will have the base BC. So, and similarly, we can have other triangle also, which are same with the definition that it will be formed between these two parallel lines, and the vertex of these triangles will be on um one parallel line, and the base is fixed BC. So all these triangles are not same in structure. They are not fixed. But for all these triangles, the area would be, if the length of BC is B and the distance between these two parallel lines are H, then area of all such triangles will be half into base into height. Okay, so you'll remember that in these cases, you even don't have to fix the shape of the triangle. So if such situation is there, you can find the area. Now we have completed the triangle part. Let's go back to quadrilateral. So we have already covered rectangles and squares. Let's draw, or let's talk about very interesting figure which is called parallelogram. So first we need to describe what a parallelogram is. Okay. So can anyone tell me what a parallelogram is? Yeah, how do we define parallelogram? Parallelogram. कोई नहीं बोलेगा. यही दिक्कत है हम लोगों के साथ. So parallelogram is an kind of quadrilateral which opposite sides are parallel. So the only basic definition that basic element of the definition is that, uh, just a second. So the only basic element of the definition is that opposite side must be parallel. So with this definition, you will say that, sir, rectangle is also a parallelogram, square is also a parallelogram. Even if opposite sides are parallel and equal, then it will be called rhombus. So this will be called rhombus. So all squares are rhombus also. So when we say parallelogram, it actually covers all these figures. When we say rhombus, it actually also covers square with some condition. So you need to remember this, that Parallelogram is parent figure. You can suggest all the rectangle, all the quadrilateral whose opposite sides are parallel will be called parallelogram also. So when you visualize this parallelogram, we can take any of these side as an base, and the distance between the parallel line which we are taking as a base with the opposite side, we'll call it height. So if we have such kind of parallelogram and we have been given B and H, so what we'll do that I'll make a rectangle out of it. Okay, so this will be H, and if this is B, then this will also be B. So what you can see that this triangle and this triangle is equal. Although here we have not drawn to a scale, so these are not looking equal, but these are equals. So the area of parallelogram will be same as this area of this rectangle, which is B into H. So uh, within condition which was there in triangle also, that the base and height should be corresponding. So whatever side we are taking as base, height must be drawn on that side only. So now again the same question which I had asked you in the case of triangle. So if there is a if there is a parallelogram and you have been given the two sides, one is A and one is B, can we calculate the area of this parallelogram? Can we calculate the area of this parallelogram? जल्दी बताओ. Can we calculate the area of this parallelogram? No. Ankit, no. Why? Because just these two figures, we cannot fix a parallelogram. है ना? Because let me give you an example. Let I have drawn a different parallelogram which has same length, like this length is also A. Or you can draw another parallelogram of the same length. So all these parallelograms have two sides which of A and B only. So uh, as we move down with this particular angle, the area will reduced, and when we move up, it will be a area will increase. So we can have infinite number of parallelograms with A and B length. A and B length. So we cannot actually calculate the area of this parallelogram. So why we are talking about this? Because most of the time you will be using this only to calculate the area of a parallelogram. But for CAT or for even maybe in all the exam may ask, because these are very basic things. So if they are giving you such thing like in a DS question, now the length A and B is there, and you have also given the measure of angle, like this is 70 degree. Now can we calculate the area of parallelogram? Then it is yes, because with this measurement you cannot draw any other parallelogram. Then the size of the parallelogram is fixed. Okay, size of parallelogram is fixed. So you actually can calculate the area. Now, how you can calculate the area, that's a different case. That is a different question. But for a DS question where you have been just asked that whether we can calculate the area or not, you can. And how you can calculate, you can actually find the height with the angle also. So we will not be talking about that right now. So again, we'll go back to the concept that we have studied, that in you don't have to fix the uh, parallelogram, size of the parallelogram always. Sometimes you can take the leverage of parallel lines again to tell that the area of parallelogram can be calculated without fixing the uh, parallelogram. So let's say there is a base again, BC, which is having B as an length. And with the base, this base, we are drawing parallelogram in this ECD like this. And we can draw multiple parallelogram where we are fixing the length of one side and height of the parallelogram actually. So in all these cases, parallelogram, the size of the parallelogram is not being fixed, but the determinant of uh, finding area of parallelogram is being fixed. So in all these parallelograms, the base is B and the height of these parallelogram is H. So for all these parallelogram, all the parallelograms will have area as what? B into H, like we have calculated. So this is another important fact which you need to know. And now let's go back to another kind of parallelogram, which is rhombus. So when we have a rhombus, we have added one more thing to our definition of parallelogram. So what is extra than parallelogram here? Parallelogram plus adjacent sides are equal. We can say this fact as this, or we could have also say that all the sides are equal. So adjacent sides are equal. So when we are adding this statement to the definition of parallelogram, it becomes rhombus. Okay. The basic element of definition of rhombus is this only, but we can have multiple properties because of this condition also. So one of the property is that the diagonals of rhombus will divide each other perpendicularly. Perpendicularly means the angle of intersection would be 90, and not only perpendicularly, it will bisect each other perpendicularly. So the diagonals of rhombus bisect each other perpendicularly. So we could has perpendicularly. So what happened because of this definition? We got another way to calculate area of this rhombus. That doesn't mean that we cannot use the uh, definition or formula of parallelogram. So this we have already, but with this extra property, we got a different way to calculate the area. How? So now we have basically two triangles. Let's call the two diagonals as D1 and D2. D1 and D2. And what do you see that we have basically two triangles here, uh, both as a base as D1 and both has a height of half of D2. So the area of rhombus will be 2 into area of these two triangles, which will be half into d1 into d2 by 2. So this will also, which will be d1 into d2 by 2. So this is also a formula for area for a rhombus. Okay, which is extra. Like we have the formula of parallelogram also. If we have side and height, we could have calculated the area as a into h also. But this could be another way to find the area of a rhombus. Now the different other kind of figure, other kind of quadrilateral is we call it trapezium. So trapezium, how the trapezium is defined? We have two opposite sides parallel to each other in a trapezium. So you can just see the rectangle here where you have AD and BC sides are parallel to each other. So how do we write it? AD and BC are parallel to each other. So basically, if you don't have any measurement, you can find the area of any shape by putting it on a graph. So you have a graph here and you can just put any figure and find out how many boxes are there in between. So this is a way where we can just calculate the area by putting it in a graph or finding how many boxes can be fitted into this closed figure. But if there is a shape which helps us in finding the area by some of the measures, like in this case, if you have this side, length of this side and length of this side, and if you also have the height of these hello, hello, hello.
Yes, sir, you're audible.
मैं कॉल को रिस्पॉन्ड कर रहा था ठीक है तो इफ यू हैव these three figures with you it becomes easier है ना you don't have to use this way to calculate the area of this particular figure so how it becomes easier to calculate the area by these three figures we can divide the trapezium into two triangle है ना into two triangles. So one triangle, this triangle will have a base A and height H because the height from B to AD will be same as H. Another triangle is this where base BC will act as base and height of the parallel line will act as the height of this triangle. So basically what happened, the area of trapezium ABCD can be calculated as sum of the area of these two triangles. One is half into A into H plus second one is half into B into H. And we can just take the half and H as common. So you'll basically find what? Half into A plus B into H. And to remember it in words, we will call that the area of trapezium will be half into sum of parallel sides into height. So half into sum of parallel sides into height of the parallel lines. So this is how we calculate the area of trapezium. So now one more important figure is there. We need to find area of that also. And other areas, if you will find any, it can be derived or area can be calculated with these formulas also. So one important figure is left, which is circle. So how do you define circle? Circle is an what locus of a point. You know, somebody says that locus of point is equidistance from a uh, particular point. So circle is basically uh, a circumference which revolves around a center. So center, if the center is C and the distance which is equal for all the points of the circumference is R, it is radius. And if we'll increase the line of the radius to the opposite end, the entire line will be called diameter. So we have important figures like circumference. You know what is circumference, diameter, radius. So these three things are there. And one of the important uh, concept that you should remember is for any circle, any of circle of any size, the ratio of circumference and diameter will always be constant. So this is not going to change. You may take any sized circle and it will always be equal to pi. So before going ahead, I'll tell you that we take the value of pi as 22 by 7. It is not the exact value of pi, it is approximated value of pi. Approximated value of pi. And the decimal value of pi, we call it 3.14 only. But this is not, it actually goes on. So pi is an irrational number. Pi is an irrational number. It cannot be uh, represented as p by q. Yeah. The p 22 by 7 that we take as a value of pi is approximated value, but it is very useful for a smaller size circle. So we frequently take it, and everybody will accept that. 3.14 is just the decimal representation of this, but the pi value is will go ahead, yeah, and we will have infinite number of terms in this. So this is always constant, and with this particular definition, we got what? Circumference is equal to pi into d, and you know d is 2 time radius. So pi into 2r. So the area of, sorry, the circumference of a circle is 2 pi r. So why did we actually convert it into this? Both are same. So this is a general practice of writing a number like this. We actually write the numbers first, then the constant part, which is being represented as any symbol second, and then we use the variable. Here r is a variable which can change circle to will change with circle to circle. So with this formula, you can actually calculate the circumference if radius is given, or radius if circumference is given. Now to calculate the area of this circle, let's cut this circle into four parts and arrange it in this way. Two as this and two part as this. So I have not drawn it to a scale, but you can just visualize that one, one, two, three, three, four, four. So what do you see here? That these two will be half of the circumference, which will pi r. Here also these two will be half of the circumference, and these two lines are radius. So if we'll divide the circle into further into infinite parts, so first we'll start getting a figure like this. We'll have smaller parts, So all the curves part will lie upside and down, and this will be R. So if we'll take the infinite parts like this, it will actually become a rectangle whose one length will be pi r and other length will be r. So by this way, you can easily say that area of a circle is pi r into r, which is pi r square. So through this, with this we have actually completed the entire area part. Now, in next class, probably day after tomorrow or in this week, sometime in this week, we will be covering everything related to volume. Okay, and then we will till then you can do the exercise of area, and also you can watch the previous lecture of volume, and then we will be having class for area or volume of complex structure, not complex structure which are being made by the use of two or three type of figures, or when a figure can be divided into multiple simpler figures. So this is all for today's lecture. तुम लोग